our previous simulation. So diving back to our reference material, let's go take a look at it. So you can see how the points kind of slowly grow over time. They kind of make this V shape. Depending on how you would like your universe or supermassive black holes to grow, you don't have to do this V shape, but it is recommended. We're going to falsify it a bit and just keep it procedural. So, diving back into our file, I'm going to go over here to our group range. What this group range is doing is just selecting the number of points from between the ranges of 1 and 5, and we're just calling it group 1. We're going to then delete those points and delete non-selected, so everything inside of group 1 we're going to keep. Then we're going to do another conject adjacent pieces, so you have that kind of V shape going. Color it. I'm going to color it black, so you might see it disappear for a bit. And then we're going to add a sphere. And I'm going to turn on this so you can kind of see where the points are. And basically what the sphere is, it's going to be kind of transferring its color to our points down here. And I've just moved that circle from 0, 0 into the right upper hand corner of our grid. The color of the sphere is red. So if you go down to our attribute transfer, you're going to see that our attribute transfer is animated over time. So you're going to see the slowly appear into red. And you can, depending on where you want to move this ball, this is where your points will be firstly attracted to. So if you move this ball down over here and we go outward like that, then your points or your magnetic fields will be attracted to this area first and then grow outwards. I hope that makes sense just a little bit. And then we're going to scatter some points onto there, which is using the density attribute CD. So these points are kind of growing out. One thing I do notice is that they're jittering just slightly, so I'm going to add a time shift just to make sure we don't screw anything up. And the next thing I'm going to do is just delete any points that aren't red. Basically, it's growing out like that. We have our out attract null at the end. So to proceduralize this chunk of the setup, we have another controller, which is called controller attract. So I'm going to go here, color this bright red again, just so I know where it is. And because we have our scatter over here in our other null, or our other controller, we're not going to add it into this one. That's going to create some hectic issues. So what we're going to do instead is dive inside here and work with everything inside this network box. So we're going to go here for bid linking, go to our group range. So I'm going to say, not going to select the filter here, we're going to select the filter here. So where it says of, we're going to shove it into there. So of selected total, boom. Delete, pretty self-explanatory, we don't need to add it. Connect adjacent pieces, yes, and yes. So we're going to add another separator between them in a folder, top, and then bring them all into that folder, and we'll call this folder Attractor. Then we have our color. We don't really need to change these. Red and black is a really safe range of colors when you're dealing with something like this. And for our sphere, I think I'm going to leave the radius the way it is, but I am going to add the center into here because if you want to change the position of our sphere, that's going to be the best way to do it. Then we're going to go down here to our attribute transfer. And we're going to also add our distance threshold. So you may already see that this is getting a little bit weird. So I'm going to add another folder under attract, and I'm going to place these three in there. And we're going to name this folder attrib transfer. Then underneath here, we are going to add everything below the attribute transfer, which is our scatter points and pretty much nothing else. And there we go. So now we get to rename everything the way we choose. So if here of selected total, we're going to just do range. Search radius. And max search points, I think, are pretty self-explanatory. Center, we're going to do sphere pos for the sphere position. Distance thresholds, which is attribute transfer. So I'm just going to go attribute thresh. And then for force total count is our number of points. And you might say, hey, NPT stands for number of points, but I'm old school where I like to spell things out. We apply, accept, and if we go to our controller, we should see something really cool. So we have our attractor and our attribute transfer, and we're all good to go there. So going over to the fun bit now, we have our emitter. And our emitter is now a bunch of points that slowly kind of grow over time. And just have a tiny little bit of growth to them. I apologize if you hear any noises in the background. Currently there is a snowstorm in Toronto. So right now we're going to delete all the attributes we don't need, minus CD and infection, because we're going to need those later. We're also going to delete points that are in a range, because we don't really need all of them. And then we're going to time shift this just to make sure, once again, they're not jittering. I'm going to couch this out again, just to make sure I'm good to go. And now we have our pop nets, and these are going to be fun. So if you can see here, we have a pop net, and diving inside, we have our first source points. And basically what we're going to do here is change the emission pipe over to points, make sure it's using the first context geometry, and the constant birth rate is 45. Everything else will not change. The pop attract has a force scale of 1.29, a maximum distance of 3.62, and it has a SOP path of these parameters. So basically, once again, it's grabbing our out attract area. And then I've added a drag, just to drag everything together and make sure it doesn't bounce off our grid. So if you can see here, they're slowly moving together. They're slowly being attracted to that middle section where we wanted them to go. The second pop net is a little bit different, and you can see some cool, interesting structures starting to happen. Dive inside, we once again changed our source first input to points, and the birth rate is about 5,000, nothing else has changed. Only thing we've added is a point replicate, of which we've animated the constant birth rate over time from a 1 to a 12. So it's growing over time, exponentially. The shape of it, I've changed to a cone and just given some variation of how the particles should spill out. And I've added some noise to the way they should spill out. So if we play that back, it very much starts to grow like this. Over here, everything is normal. So jumping out, we have an attribute randomize. We have p-scale, which is min value of 0.02 and a max value of 0.2. And this is where it gets a little bit confusing. So I'm going to chuck this in the garbage because I don't need it. Because my first pass at this project, I was like, in the PopNet, I can probably add some colors to the particles, no problem. And that's all we'll need. We'll know we're going to be working with the CD and infection attributes over time and manipulate them just so that when we put them into our final product, they look exactly the way we want them to do it. And part of that is that you have to manipulate the CD attribute early on. So I've added a point VOP, and inside it, we are adding the velocity and the age together into here, and then we're ramping it to a color ramp, and then punching it into the CD output. So if we go look at this, we can see the colors growing over time like this. And that looks very, very colorful, and it looks almost like what we want. So we're going to keep it. Then if we go to out particles, we've added a null and another point VOP. If we dive inside here, I wanted the CD to reflect the P scale of the particles. So in this particular case, the spline ramp is being put into a bind export, which is labeled as P scale. Diving back up, I didn't show you guys what the colors look like. These colors are also animated over time. So if we play it back, you can watch these colors push themselves like that. So just slide them over like so. And if you can animate them any way you like. In this particular case, I just took every individual point minus this guy over here and just moved them to the side like that. Over here on the point VOP ramp, we have something really tiny going on. So every single value is punched really, really low. And you can see it here. Over here I have my visualizer, so I can see how small these pieces look. So if we go over here, we let Houdini think, we can't really see them because they're that tiny. But they are there. Also, I'm going to turn off my black background so you can probably see them better. They are very tiny, so yes, they are there, and as long as you can see them with your point visualizer, you're good to go. So the next thing we're going to do is add a VBD from particles. And the only reason I'm suggesting you do this is that when you're transferring your colors to your grid later on, you're going to run into the trouble of, my particles are not behaving or looking like they should. The only way you can really do that is by remeshing them before you feed the attributes into the grid. So we've got a VBD from particles, and these are the changes. We've then got a converting these to a mesh. Turn off my visualizer there, so if we play that back, the mesh kind of grows a bit. And then we are going over here to our attribute transfer, and we are transferring basically the color back onto our mesh. We only need the color. Let me see. Yeah, we only need the color. So I'm going to go CD, and these are the settings. And then attribute blurring them just a little bit so the colors get mixed in. And then we jump over here. I'm just going to expand my network box. And you can see already when I click this, the mesh already aligns very well with our grid. And if we go over here, we've got an object merge that's going into this object that is going back up to the top and grabbing our null that says out grid. It is then subdividing that grid and then adding a color to that grid, which is white. And now if we jump down here, we've got an attribute transfer of these. Now you may be looking at this and you'll be going, this looks like somebody in my JK art class took a bingo puncher and just stamped the plane. And yes, it does look like that, which is why we've added another attribute VOP. So if we go over here, we can see, oh wow, the color has changed. And the reason it has changed is we've done something kind of sneaky to the color. we've gone in here and we've added another ramp, which is feeding the color back into the color. And it is default ramp. What this is doing is just remapping the color just a little bit so we have more playtime, and also keeping the white area of the grid as well. So if you play this back, these slowly kind of grow into each other. And we kind of have that similar pattern that we saw at the beginning. And again, depending on the speed and the mesh and all your other factors, is how this is going to play out. So you can see them growing just a little bit. So over here we've animated our blue section of our little position. So basically what this is doing is, you can see the blue shrinking as the magnetic fields are going from hot to cold as they're growing. And it's slowly going blue and it's mapping out or crushing the white. So this is where the tutorial could end for you, but if you want to make this just a little bit more interesting, you can make these colors just pop out of the ground just a little bit. So if we move our camera like this, see they have kind of a lift to them. And you can create this lift by adding a group expression, which is going to grab the color under this value. I realize we don't really need the other half of that node tree, so I got rid of it. But yes, it is grouping the majority of our infection and then adding a soft peak to it. So what the soft peak is doing is going off the color, and we're going to delete the old group that we no longer need. So it's taking the group color from our group expression and just peaking it upwards. So just creating some kind of rifts in the environment. And that's pretty much it for this one. Now, I recognize that it's not completely identical to the simulation that we saw, but it does move in the similar pattern, and depending on how you want to adjust your universe or the growth of your universe, you can do so very easily with this setup. So basically, the way we can proceduralize it just a little bit more by once again putting everything into our controller. So let's jump into that as well. We'll color this one red. And we'll dive inside. So our emitter, don't really need to do anything for that. Attribute delete, we're fine there. Deleting there, good to go. And our points, we're probably wanting to add save to disk there. So we're going to go here, create a folder, and name this folder particles. I say that, not knowing what to call it. Okay, so I've just temporarily dived outside our controller. I'm going to go to our PopNet because I just realized something really cool. So we go to Edit Parameter Interface, and you close all these folders. Okay, another folder. And we can call this Parameters. And we can forbid linking. And diving inside our PopNet, we can add our constant birth rate, our force, which is our force scale. Go inside there. Thank you. Maximum distance. Gonna add a scale and separator in between them because they're different nodes. And our air resistance. And that's pretty much all we need. Great. Apply accept. Go to the surface. And suddenly we have a different thing called parameters. Good to go there. So we're going to do the same with this PopNet down here. Go to the parameter interface, close all the folders, forbid linking, add a new folder called parameters. go inside, and the only thing we're really going to change, we'll add our constant birth rate just in case you need it. In this particular case, I don't think you will. We'll go to our pop replicate. I'm definitely going to need to change stuff here. So attenuation. You will always need this noise, so I'm not going to change it. The shape you might need. Size for sure. Uniform scale, yes. Birth, yes, we will need that. And I think that's all you need, so we'll go apply, accept. And if we go over to PopNet1, we will see our parameter folder. Suddenly, PopSim's got a whole lot easier. Thank you, side effects. So going up here to our controller, we're going to go back into our particles. We have our save to disk there. I'm going to add another folder called PopNet or first particles. And then we're going to go over here, just drag everything into there. And of course it won't let you, so you go unforbid. We'll add our separators as well for consistency. Uh-oh. And this is where I'm going to save because I just had Houdini glitch out on me. And we're also going to add another folder, particles, called secondary. Go over here. And I think we're good to go from there. The next thing I'm going to do is go to our attribute randomize to our p-scale. And the next thing we probably want to do is grab our min value and our max value. And we'll rename these max p-scale and min p-scale. Then we go to our point fop, and we have our preliminary color. So we're going to take the entire ramp itself and stick it on our particles, because we can do that. So we're going to apply and accept to make sure that's going right. So far, that's pretty good. So the next folder we're going to create is going to be different. We're going to call it out particles because we have our null down here. And that's going to handle all our VBDs, which is going to be great. I'm also going to save once again. So going back into our controller, go here, and we're going to add our new folder. So we're going to go like that. Go to our point fop, which is controlling our p-scale again, and just stick that ramp into there. Of course it won't let us. So ramp p-scale. Ramp. We'll leave that one for now. And then for visualizers alone, I think they're good to go there. And we are going to add a separator. Voxel size, point radius, and you will need to change the minimum radius in voxels. Separate that. And your attribute transfer as well. Attribute blur. I think you'll be good for 6 iterations. I'm not sure if you'll need to change it. This one, I'm hesitant, so I'm going to add it anyways, and as well as the blend width. So now we're going to rearrange and label all of this. So once again, we're going to add a folder into there. I think what we're going to do is take these ones into here and do that call cd We're also going to voxel size perfect, point radius scale, going to change to voxel, minimum radius in voxels should be good, kernel radius, CD, distance threshold, blend width, separator, distance thresholds, sec CD, just so I understand that that's the secondary one. And then if we go down here, we're going to close this and add another folder. So our out particle folder name is final, just so we understand that this is the final step of the process. We're going to add the color into there. We're also not going to touch our group expression. And we're going to choose our soft peak, distance, and radius. Then we are going to go down to our separator and click apply accept, bring this down and have a look at it. Particles, and then final, we can switch over. So that's pretty much all you need to do, and I hope you enjoyed this tutorial. My name is Kate, and I'll see you in part 2 creating magnetic fields of the universe. Bye!